Welcome back to R for Economics. In this video, we're going to be talking about principal component analysis. Principal component analysis uses the stats package, so we'll bring in that library and POYR, and we're also going to bring in the GGB biplot, and that's just to demonstrate how we can use this. Okay, we're going to bring in our MT-cars database, and we're going to just take a subset of that, which removes the binary things like imports or domestic. Now, the operator that we're going to use is prcomp, which is a commonly used, and we can see what we end up getting. We end up getting a standard deviation of 2.378. And if you remember this from the eigenvalues, eigenvectors video, this is the same data set, so this is going to give us the same standard deviation with the same proportion of the variance and the cumulated proportion. Now, one thing to note is that after about this third principal component, you've accounted for 91 or almost 92% of the variance. In many cases, this should be sufficient to get an idea of how many factors you should be using if you're going to generate factors from your eigenvalues, eigenvectors. Now, the principal component analysis uses the same approaches as the eigenvectors and eigenvalues. Now, we can look at this cumulative proportion or even the proportion of the variance by looking at scree plots, which will show that this is dropping down very quickly. And you can see that this is usually called an elbow plot or something like that. So where it bends in the elbow around 3, everything after that is providing very little variance. We can also look at the cumulated proportion of the data, and we can see that it's rising quite quickly and stops. And this is another look at this elbow that we see. And we can see that this is a proportion of the data, and 92 is about right here at 3. Now, another way to look at the data is to use what's called a biplot. And here we're going to just identify which countries are for each of the vehicles in our list. And then we can generate a biplot in this respect. Now, this tells you where those factors are and what's important and the direction that those are affecting the model. And you can see that a group of them are moving off to the right, and a group of them are moving off to the left, and some of them are going up, some of them are down. But there seems to be at least a divide on either side of 0. Now, we can label these if we wanted to look at the types of cars. You can say, well, if we're looking at this, we can say that, oh, these factors seem to affect these types of cars and these ones. Now, this can be hard to examine, so we may want to color code these, and by grouping them by the MT cars, we can see that ellipses around the US cars seem to be on the right-hand side, where things have more cylinders, more horsepower, higher weight. And then things on the Japanese side seem to have more miles per gallon, DRAT. The gear ratios are slightly different in CUSEX. Okay. And then the European cars seem to just try to encompass a lot of these things all at once. And this might be because they're specialty things like Porsche, and they're also Mercedes as well. If we just want to look at these in dot form, we don't care about the actual car manufacturer, we can see that the blues are really capturing this. Another alternative is the prcomp command, which does the same, has the same overall properties as prcomp, just with a slightly different form so that you can see what each of the components are doing. And then you can biplot the prcomp as well in the exact same way as we had for the prcomp. Okay, that's it for principal components, and we'll see you in the next video.